I guess the previous session was really good, so it ran a bit over time. I had to set up super quickly, but I think we are ready to go. I'm great. It's great to see you all here. I appreciate the attention and trust. I know that you are missing 2 normal sessions because the deep dive is longer, so it overlaps with 2 sessions, but I promise to make it worth your time. And this is the first time that I'm doing a deep dive by myself. I did it before in the past, but with co-speakers. This is the first time doing it by myself. So I'm super excited and a little bit anxious. So if something goes wrong, apologies. This will all be live and unstaged. And I decided to do it like the cool kids, no slides. So we will have our little agenda here in Markdown, and we will cover all those topics so that hopefully you will be prepared and feel confident to use GraalVM, and namely native image, in practice. And from what I've been told, I need to make a break in between because this is a deep dive. It's a long session, so I think we'll do it like 50 minutes, 10-minute break for mental health, coffee, water, restroom, etc. And we will come back for more GraalVM content. And the way it will be structured is it will be all native image, and my plan, if I can manage to stay on track and not chit-chat too much, will be that we will cover those topics in the first half, so building an application, using libraries, optimizing for peak throughput, deploying, and then for the second part, we will switch to security demos, which I love. I think they're very cool, and I'm very excited about them. We will talk about monitoring, tooling, and then we will talk about some forward-looking projects that we are working on, but we haven't delivered yet, but what we see as the next big thing for GraalVM and for native image. So let's start with the overview of GraalVM, and we have been doing this for a while, so I'm kind of hoping I don't need to do this whole pitch that GraalVM is a polyglot VM and all of that. I hope you can, at this point, tell me that instead of me. But specifically in the context of Java, how many ways do you think there are to run Java on GraalVM? So give me a number. How many ways? I see people trying to make gestures, but maybe you can just speak out. Yeah, how many ways, like different ways, there are to run Java on GraalVM? 2. That's a good guess. That's what I would expect. Any more guesses? OK, I think we're going to roll with 2. So there are 2 answers to that question, like 2 obvious answers. One is you can run applications on GraalVM as a JDK, and GraalVM is a normal JDK, just like any other JDK of your choice. Maybe you like OpenJDK, maybe whatever the JDK vendor you like getting it from. And in that way, you just flip your distro for GraalVM, and you get a JDK setup where you have a brand new, very aggressive, highly optimizing GraalJIT compiler. The rest stays the same. You can use all your favorite tools, libraries, everything just works. And what you can get out of it is performance speed up in the JIT mode. You can expect maybe 10, 15% if you are lucky, performance improvement just by running on the JIT. But with such an easy migration, I think it's a good deal. Now, there is another big part of it, and that is native image. And native image is ahead-of-time compilation of Java to native executables, and this is what we will talk about in this session today. So those are 2 known, obvious versions of running Java on GraalVM, but there is one more way to do so, and it's called Espresso. How many of you know Espresso? Some people do. OK. So you might know that in addition to Java, we have this language implementation framework on GraalVM called Truffle, and that is the way how we have implemented all those additional languages like JavaScript, Python, Ruby, etc. on GraalVM. And we also implemented Java on top of GraalVM, so Java on top of Java, and that is called Espresso. Why Espresso? Because we love coffee names, and espresso is a small coffee. So we have also implemented a small Java, or rather a small JVM interpreter on top of GraalVM, and then you can execute Java on top of Java. And you might ask why, and one answer is because we can. So, why not do it? Sounds fun. But also because it enables some additional use cases, such as maybe you want to have a more sandboxed environment, maybe you want to execute part of your code that you don't really trust, or maybe you want to execute it in a container that has, let's say, a different Java version. So those are the use cases that we see for Espresso. So the TLDR is that there are 3 different ways of running Java on GraalVM, but in this session, we will focus on just one, and that is native image ahead-of-time compilation of applications. Now, a very brief intro to native image. So the way it works, if you run native image and give it your application, and as input, it takes bytecode, so it needs to be your class files or your jar. And as an output, you will get a native executable version of your program that contains the reachable code, so the code that your application needs to execute. And it includes your user code, but also we will analyze your application and pull in everything from JDK and from your dependencies, so all the things that you need, and we will put into this native executable. So you don't need a JVM at runtime anymore. You have your native program, but also you don't need to load classes, profile, compile, etc. We did all of that at build time. And this is one part of the story, and this is also why sometimes people call native image ahead of time compiler, but this is just one part of it. The other part of it is that we will also look at your image heap as we are building the application, and we will see what is safe to initialize at build time. So you can also start with pre-populated heap, and you can also save some of the time and effort populating that heap when you start the program. And it all happens at build time. So the idea that we have is to shift as much work as possible from runtime to build time, because we think many applications are started way more often than they are built. So we offer you a trade-off where you can move that work to build time as opposed to runtime. But obviously, it needs some kind of limitations on that world, because if you're executing something at build time, you need to limit what can happen at runtime. And native image operates under closed world assumption, meaning that everything there is to know about your application needs to be known at build time when you actually build your application. So this means that those more dynamic Java features, such as reflection, serialization, proxy, GNI, etc., but primarily reflection, those things need configuration at build time. And that configuration can be provided by you, by your library, by framework, but it needs to be known at build time. And as a rule of thumb, native image can do pretty much anything for you as long as you tell it at build time what needs to happen. So this is a TLDR into native image, and let's maybe take it for a spin. So I have a bunch of demos here, and I want to start with this application called Dictionary app. And this will be a Spring app. Let's first run it, see what it does, and then we will try to move it to native. So let's do Maven Spring Boot run. And I'm here on GraalVM for JDK 24, so the latest and greatest released version of GraalVM. So my application starts, and it starts in 2.5 seconds. And all the demos today will be running on an isolated cloud instance, so hopefully it will be a fair enough execution environment, not interfering with the screen sharing on anything, but separate, clean environment. So it starts and it runs, and let's see what our application actually does. Let me just zoom this in. So this is a dictionary application, and it has an endpoint that is called translations. Can someone tell me what is this beautiful language? What? Okay, I will save you the trouble. This is Swiss German. It's a very interesting language spoken where I currently live in Zurich. If you are into languages, I am into languages. It's a very interesting one to look into. If you happen to speak it or if you want to learn it to the extent that I know it, which is not much, catch me during the break and we can practice some Swiss German. So this is my app. And if we look at inside it, it's a pretty normal Spring app. So those are all our demos for today. This is my dictionary application. There is a bunch of things in here. Here are my actual application classes. It's my Spring app. We have our translation controller with the endpoint. We have our classes to work with the data, and then the actual translations are stored here in H2. And if we look at our POM XML, again, it's a pretty standard Spring web application. Nothing weird going on here yet. I have my dependencies for working with Spring Data, for Spring Web, and it all looks normal so far. For plugins, I have my Spring Boot Maven plugin. So let's say I have something like that running in production, and I want to move it to native. What would I do in that case? So in general, my recommendation will be to always start with native build tools. And native build tools is our Maven and Gradle plugins coming from the GraalVM team. You can choose Maven or Gradle, whatever works for you. I'm a big Maven fan, I must say, but whatever works. And then the way to work with this is you can just go to our Getting Started guide, pull from there the plugin, enabling the agent. Okay, this is the agent. But yeah, you just add our Maven Gradle plugins, compile your application, and it works. And this is the way I say this is important is because through using our plugins, you will get access to a better, more easier to use facilities for building, testing applications, making libraries work, etc. But I will not go this way because I have a Spring application. So what I would do in my case, I would go to startspring.io and I would add my dependencies. And I'm very happy that the page now remembers my default. So for me, it's always Java and always Maven. So if I want to add dependencies, I see native image at the very top of the list here. And if I look inside the project, the part that is needed for native image is this native Maven plugin. And as you can see, I'm at startspring.io, but the plugin is coming from our team. So when you add native image as a dependency, the Spring guys are kind enough to include our own plugin as this unified interface to work with native image. And in general, if you happen to be a maintainer of a library, of a framework, and you want to make it friendly towards native image, I would suggest that the way to interact with native image would be this plugin, because it is a unified, nice way to do all things native image, one place to configure, to make libraries work, etc. So let's get ourselves this plugin, and let's head back to our project. Now, this looks good to me, and I could have leave it as is and compile it now, but let's say I'm emulating the use case where I'm still, let's say, at home, at work, and I want to build this application, and I'm still working on it. So if I'm still working on it, one thing I would want to do is I would want to add a configuration block where I can pass arguments to native image. And I want to pass one specific argument, so I need one more build arg block. And the argument will be -ob, and this is a quick build mode in native image. So you can think of it as a development mode versus production mode. So I'm saying I'm still working on my application. I want my build back quickly to me. So please make the build faster. I'm not ready to deploy to production yet. I don't care about the speed of this application yet. I just want to have my build quickly back to me so I can verify that it works. If I was ready to deploy this to production, because the way it works, it removes some of the compilation optimization phases, so your application will not be as good in terms of peak throughput, but I don't care because I just want to validate that it still works. If I'm ready to deploy it to production, there are two ways to do it. I can either remove this section and let native image do its thing and choose the optimize for throughput flag, which usually would be -02 or -03. So I can either specify manually which level optimization I want, or I can just remove it and build as is. But let's say I'm still working on the app, so I want to build it with this quick build mode. And now what I can do is Maven native compile, and this will trigger my native image build. So as this builds, it will look at my system, analyze how many resources are available, and also make some decisions of how many resources this native image process will occupy from my machine. So this is a rather good machine. It has 32 gigs of RAM, and it says already that it has detected that on the machine, but it has heuristics inside to see how many or how little resources to occupy so that you can keep having your work done on this machine, but still your build will be completed in a reasonable time. So this says it will not necessarily occupy 10 gigs, but rather it says this is the max limit of the things that I want to occupy. And when I compile this on the stage, there usually comes a time when we see this and people tell me, oh my God, Alina, this build process is so long. Why does it have to be so long? I don't have the attention span for this. Do something about those build times. And I'm with you. I also don't have attention span for long build times, but check this. So if you have looked at my app, it's maybe like 5 classes. But I am using the JDK, I am using Spring, I'm pulling in some Spring dependencies, and all of that combined gives me great developer productivity, gives me good peak throughput when I'm running my application, but this also means that my fairly simple web application has, as native image detected, 33K reachable types, 51K reachable fields, and then almost 200 reachable methods out of 300 methods total. So reachable means the analysis part in native image looked at the application and has detected that those things are actually needed when I actually need to run my application, as opposed to 300 methods in total in my project. My point being that even for this rather simple application, there is still a lot of complexity under the hood that makes me productive as a developer and makes my application fast. But the price of that complexity under the hood is also the size of my project. In the meantime, as I was chit-chatting, the application already compiled in 1 minute. Now, you can tell me that I used a trick and I used the quick build mode, but without the quick build mode, it would have been maybe 1 minute, 30, 40 seconds. So it speeds up the build, but not orders of magnitude. It maybe speeds up by 20, 30%. Now, my application is compiled, and what I actually need is this dictionary, which is the executable, but also the courtesy of AWT, I'm getting some extra files in here. But what I really need is just this native image executable. So let's run it. Let's do target dictionary. And it starts, and if you remember previously, it was 2.5 seconds. Now it's only 147 milliseconds. And if we go back to our endpoint, translations, it does the same thing. So it's still working, it's still operational, but now it started so much faster. And fast startup is just one part of native image. You might know that native image applications start fast, but this is not where the benefits end. So sometimes I get this question, let's say I have a longer running process, can I still use native image? Is there something in it for me? And the answer is yes. We will talk about many of those benefits in this session. One of them, and I think one very important, is lower resources usage. So unlike the JVM, we don't need to do as much work at runtime when we actually run the application. And this means that we don't need this whole infrastructure anymore that the JVM needs, that loads your classes, interprets, profiles, compiles, etc. And this also means that native image will use way less resources at runtime, being CPU, memory, even electricity. To put this more into kind of numbers, let's run this application with one more command attached to it. So we will use time to observe our process. And now when we run our application again, and go to the endpoint and emulate some user behavior. So let's say this is deployed somewhere and we have users sending requests, and I have sent, let's say, 3 requests per second across the span of 10 seconds. So it was not under high load. We will do high load down the line, but let's say it was under some load. And those are the performance counters that we see. CPU that we used was just 1%. Granted, our application is maybe trivial, but still it was under some kind of load doing some job, and all that it used in terms of CPU was just 1%, because for native application there isn't that much to do anymore. In terms of memory usage, we are at 140-ish megs of RAM, and this is basically giving the application the whole machine and saying, do your worst. Like, we were not limiting the memory in any way. We were just saying, run and use as much memory as you need. Obviously, if you're going to hit this application with more load, it will consume more memory. But in this, let's say, small load, not so loaded state, it consumes this little memory, and it can be tuned down even further if you want to limit it, such as with XMX settings. So this is something a native image application can do for you. So let's say, okay, I convinced you this all looks good so far. We have migrated our application, and we have seen that indeed it will be nice to use those native build tools. And then if we measure the resources consumption of our application, we will see that it uses now way less CPU and way less memory. So let's say I convinced you maybe, and you want to go home and you want to try to build something like that by yourself, but you want to use some libraries. And if you use libraries, how would that work with native image? What are the things you need to know? So you might have heard, or maybe you have even tried to use some libraries when you are building an application with GraalVM and native image, and sometimes you would run into some kind of error, especially if you were doing it, let's say, 2-3 years ago. Where are those errors coming from? So we have said that native image builds applications under closed world assumption. That means that those dynamic Java features, mostly it's typically reflection, require configuration at build time because they are too dynamic. So they are typically resolved at runtime. There is no way to know at build time what will happen in terms of reflection. So how does native image work with it? First of all, there is even built-in support for reflection in native image. So some of more kind of trivial, predictable reflection calls, such as, I don't know, class for name, native image can statically figure out when it analyzes your application. But what to do in more complicated cases, especially when your library that you want to use uses reflection and you try to build your application and it doesn't work. So here we will go into this section about using libraries. And this will be a bit more scary, so I will try to go through it fast, but this is something important if you want to actually go and build applications with native image. So how can you use libraries? And by libraries, the main kind of candidate for things going wrong will be reflection. So how can you use applications that are using libraries that in turn are using, let's say, reflection? And in general, what is the solution for using libraries with native image? And here we have a number of bullet points that will help us use libraries with GraalVM. And this is going from the best case scenario to a scenario where you need to apply a bit more work. So this is going basically from best case scenario to the worst case scenario. Now, the best case scenario would be if a library, maybe it's a brand new library, doesn't use that heavily reflection. And this is a newer trend, but we see this happening lately a lot, where is my deep dive? Where when new libraries appear, they would be maybe built in a way that don't use reflection that much. So yeah, this is the one that I wanted to pull up. So this is a library that was introduced recently, but there are more and more of them recently, where libraries are built and launched in a way that maybe don't use reflection that heavily. And reflection is a powerful tool. It's very useful in many cases, but also there is this opinion that it adds a bit of complexity and overhead. So if a library can avoid it, then it will be native image compatible out of the box, or maybe at least not use reflection that heavily. So this is obviously the most likely scenario. If you're using a library like this that does very little reflection, you will be good in native image. But clearly, there existed many libraries before native image came to be and became popular. So what to do if there is some existing library that needs configuration because it breaks when trying to compile with native image? Now, the dictionary application that I have showed before is using H2 as a database, and I like showing that example a lot because in the past, I had a different demo where I was using H2, and then it was breaking because it was using reflection under the hood, and I was showing people how to fix it. But now I don't need to do it anymore because H2 added support on their side, and it looks something like this. So if we go at the H2 source code and on GitHub, there is this file inside H2 itself in a known location, and the location is meta-inf native image. And this file tells native image what needs to happen at runtime in terms of reflection. And this is the best way for a library to add compatibility for native image. So if you happen to be a maintainer, or if you're in touch with any libraries maintainers and you want to use that library in the native image mode, the best thing you can do is go to them and ask them politely, because all open source maintainers are busy people and they have many feature requests coming in. So ask them politely if they would consider adding something like this, or better yet, if you can contribute it to your library of choice, this would be the best way to proceed. But also we realized that, again, many open source projects have small maintainer teams and they are spread too thin, so not all of them can add this support immediately, and that's totally understandable. So what to do if you want to use some kind of library, but it doesn't have that support for native image within the library itself? In that case, you would think that it would be great if there exists something kind of like Maven Central, but for native image configuration. Because maybe one of you in the room wants to also use H2, and it would be nice if you did not need to figure out that support by yourself, but you can just go and pull that configuration from somewhere. Now, we, along with our community, saw the same thing, and for that we have created a centralized place on GitHub called GraalVM Reachability Repository. And this contains a long list of libraries and projects. And in each of those folders, for each of the versions, there exist configuration files for native image. So this is a centralized place from which you can just pull that config in the format of JSON files and make your projects work. Now, this also brings me back to that project, to that point that I have made, that please add our native build tools, our Maven and Gradle plugins, because those plugins will pull this config automatically. So they are, because this is also our project, they know about this repo, and they will look at your project, at your dependencies, and will pull config from here automatically. In the past, this was an option. You needed to enable access to this repo in your Maven or Gradle plugin config. Now it's always on by default. If you're using our plugins, all this config will be pulled and resolved for you automatically through the plugins. So we have covered those 3 bullet points. So a library can be designed in a native image-friendly way. It can have config within the library source itself, or there could be a config in our reachability repo. And I would say if you're starting a new project and you're using one of the frameworks that integrate with native image, so Spring Boot, Micronaut, Quarkus, Helidon, you will stay somewhere in this 3 bullet points for new applications. But let's go a bit deeper into the woods, what to do if you want to use a library and it's not compatible. So you can see it doesn't work, there is no config, not in the library, not in our repo, or maybe let's say you have some internal library developed at your company and clearly no one else in the world will do this config for you. What to do in that case? In that case, the next good scenario is if you are on a version of a framework that supports native image. So for Spring Boot, for example, this will be higher than 3.0. And for Micronaut and Quarkus, it will be even for older versions. So usually those frameworks, as a part of native image support, will give you a programmatic way to generate those configuration files for your application. So let's look at the application that I have here, native Spring Boot. And here, let's say we have a couple of controllers for our endpoints. And let's say I have this interesting one where I'm trying to access this message field from a message class. And maybe I'm doing it in a slightly less obvious way. And this is to try and outsmart and confuse native image, because if this was a more simple call, native image could have detected it automatically. So for demo purposes, we are doing it this way. And we want, in the end, to access this string. So the way to do this is because I'm on a Spring version that is 3.4 something, so way higher than 3.0. I have programmatic support for my project. So what I can do here, if I want to make this call possible, I can go here, and I can add the annotation that comes from Spring, which is register reflection for binding. And here I can instruct Spring to get me that message from a message class. And what this will do is I'm building my application. When the Spring IoT phase kicks in, it will look at this annotation and it will generate that config for me. So this is for cases where you have some code that is not compatible with native image, but you have support from framework. And there are many flexible ways to do this. You can either annotate this class, and you can do the same on the callee side. I actually already have it from a previous demo. So I can also annotate that part that I want to call, so that class that I want to call. And then this will be available in all the different parts of my application. It will make this whole class visible in other parts of my application. And to finalize with this programmatic generation of hints, so hints are those config files for native image. If we want to do something like this, where we are loading a resource, to make it available in native image, we can use this runtime hints registrar API from Spring to generate hints for that particular resource. And I quite like this API because it's more flexible. So here we are doing hints resources, but in a similar fashion, we can do hints.reflection, GNI, and it's one API where we can create hints programmatically for all the different places in my application. Okay, let's close these things. So this is if you have a framework support. Now, let's say you are on the older version of framework. Maybe you're on a Spring that is 2.7 or something, or older, or somehow you are on some framework that doesn't have native image support. Maybe you have something that you have developed at your company internally. So what to do if you need to solve those reflection issues, but you have no support from your framework? You are still not out of luck. There is a semi-automatic way to create this config, and this comes from the native images tracing agent. So when you get a GraalVM distro and you get native image, it comes with a tracing agent that works in the following way. You can run your application on the JVM with the tracing agent attached to it and execute relevant workload to let us know what your application is supposed to be doing at runtime. And this agent will observe your application behavior and all those calls in terms of reflection, serialization, etc. And it will output those config files in JSON format that native image can then pick up and build an application that is aware of that runtime behavior. Now, I'm always asked to say that this is not a silver bullet. It will not give you 100% config, but depending on how good your workload is, I would say it will give you maybe 90-95% config, and then you will still need, it's recommended that you go and check that the config is complete, but still this reduces significantly the amount of work to make even a highly incompatible application work with native image. And then lastly, if you have, let's say, one small call, such as if I wanted to reflectively access that message field, I can clearly also write a JSON file myself. But hopefully you will never need to get to this bottom of the list where you need to do this manually. And again, if you are starting a new project, I hope that you will be somewhere in between those first 3 bullet points where that config is provided to you by a library or a framework. Now, this was maybe a bit more scary, but I think this is very important if you do want to move on and use applications using native image in production, because clearly you would need libraries, and this is how we want to solve libraries. But stay tuned, we have a very cool, kind of, I would say, groundbreaking solution for making libraries work with native image in the second part of the talk. Now, let's talk about performance optimizations. So I work on a compiler team. We developed the GraalVM compiler at Oracle Labs. So clearly, I care about performance a lot. And I always get to have a lot of those conversations with the community about JIT and IoT and which will be faster, which will be slower. And it's always a fun conversation to have. For that, let's actually do some kind of benchmarking. We are at a conference and we don't have that much time, but I think we can do at least some kind of benchmarking here in the conference setup. And for that, I wanted to benchmark this dictionary application, but honestly, it's quite simple. It's just one endpoint, as you have seen. So, I don't want you to say that I over-optimized that one endpoint. Let's see if we can do something more fun. So for that, something more fun, let's navigate to a different place. Let me maybe actually clear of this. OK. Let me move up. OK, so we will be doing benchmarking here. And what we will benchmark is a Spring Pet Clinic application. Now, for the sake of saving time, I will not start it. Should we maybe quickly start it? Spring Pet Clinic, target. Spring Pet Clinic. So we will just start a native version of the application, but honestly, it doesn't matter. And it's a pretty standard web application for Spring benchmarking, widely used in the community, where it emulates a pet clinic, where you can have owners of pets, have visits. Maybe we want to add an owner. Maybe also we don't want to leak my personal address. So let's do something like this. And it will write data into a database, and then we can hopefully also add that owner. So this is last name. Yeah, it stores some data. You can schedule visits, you can have appointments, you can read data, etc. So this is a pretty widely used in the community kind of benchmarking application, and we will benchmark it in the following way. So we will have our first benchmarking setup where we will benchmark this on C2, and C2 is the standard OpenJDK top-tier compiler. So here I will still run on the GraalVM distro, but I'm turning off the GraalVM compiler. So effectively, I have my OpenJDK kind of setup. And then we are running our Spring Pet Clinic on the JVM. We are using a tool called PS Record to produce charts of our resources consumption. Then we are giving the application 10 seconds to actually start before we even hit it with any kind of workload. Then we warm it up for a little, and then we actually benchmark it. So this is still not scientific application, not a scientific benchmarking. If you would have asked my team, they would have explained to you for like 2 hours that this is not a very scientific benchmarking. But for a conference kind of talk, this is scientific enough. And as this runs, because this takes a while, this takes 40 seconds for one run, the actual load that we send to the application is also quite interesting. So instead of hitting the application with like, I don't know, 1 million requests to one endpoint, what we do, we have our workload defined in the Lua script, and our workload that we actually benchmark right now looks the following. So we are defining a couple of parameters here, and then the actual benchmark is that we are creating a new owner, we are creating a path for that owner, we are then reading the list of owners, we are scheduling visits. So this hits all the different endpoints and does both reading and writing data. So hopefully this is a bit more fair as a benchmarking kind of setup. So my JVM version is done now. We see that the warming up round was at 500 requests per second, but then it did warm up and it arrived at 1.5K requests per second. We all know the JVM warms up, right? This is pretty normal. Now let's benchmark the same, only all literally is the same, only now we are using the native version of the application. The rest stays the same. We are even waiting 10 seconds for startup, even though with native image we don't need it, but just to be fair to the JVM, we are waiting just the same time. And then in the charts, you will actually see even in resources usage that we didn't need to wait. So who thinks this native app will be faster than the JVM? Okay, some people are like laughing or smiling. Some people raise their hands. I think I managed to convince some of you by now, because in the past, if I showed this, that AUT code versus JIT code, people will always tell me that there is no way on earth AUT comes even close to JIT. Like this is physically impossible. But let's see. So here we have arrived at 1.5K requests per second. And the native version is in the warmed up state at 1.1, but it is quite faster in this first warm-up iteration. Overall, though, I would say this is not ideal. So we are at 1.1 and the JVM is at 1.5. So, I could have said here that the JVM is a masterpiece of engineering, and it clearly is. And it's very hard to beat the JVM at its own game, all of that. And it's all true. But I do think there are some more things that we can do here. So let's get yet another tab, and let's do another round of benchmarking. And this one will be called native optimized. And let's see if we can do any better than that. Now, as this runs, we can maybe explore what is inside that mystical optimized version of the application. And in general, there are 3 key pieces to having good peak throughput with native image. The best thing that you need if you want to have fast applications with native image is you need to do PGO. PGO is profile guided optimizations, and this is an optimization in native image that works in a way that first you build an instrumented version of your binary, then you run that native executable and hit it with a relevant workload, and as it runs, when you shut it down, it creates a profile file. So it observes what your application did, kind of similar to what the JVM does when your application is running. And then it uses that collected profile information about which methods are hot, which loops are hot, to optimize for that specific runtime behavior of your application. So this is kind of like bridging the world between JIT and AUT, because you have the runtime awareness of a JIT process, but you still have all the power of AUT optimizations. And here you might tell me, but the JVM adapts all the time and profiles all the time and has access to real-time data. And it definitely does have, and it gives the JVM an advantage. But native image also has a bit more of like an obvious advantage. And that advantage is that native image has a closed world, as we said. So this means that in a way, native image has a more complete view of application than the JVM, because nothing unknown can happen at runtime. Everything is strictly defined when you build your application. So this is a very different kind of profiling, but this is not that one is better than the other. It's just that each of them has its own strong powers and strong sides. With all this, actually, let's finish with the optimization. So you need PGO. Now, you would think that it does seem cumbersome in a way that you need to do, an instrumented run and then the actual production run. Even though it does give you the best peak throughput, it does require a bit more effort from your side. And you would think it will be great if there existed something that did this for you. So kind of sounds like this could be a good task for ML. And indeed, we have a tiny little ML model in native image that if you don't provide us profiles, so in the absence of profiles, what we will do is we will look at your application and we will try to infer, to predict what your application will be doing and which part of the application it makes sense to invest compilation efforts into. And obviously, ML is not as good as the actual data, but if you could not be bothered to do the actual user-provided PGO, this ML-enabled PGO, in the last release of GraalVM, we upgraded it to a newer version. You can now expect around 8% performance improvement over not having any profiles in the first place. Now, 8%, it's not as good as user-provided PGO because there you can easily get 20%, 30%. But if you maybe have an application that is not performance critical, you just want to have good peak throughput, but it's not critical for you that it's amazing and the best possible that it can be, running with ML-enabled PGO could be the good way to go for you. And since the last release, we have updated it, so now it gives you a bit even more performance, but you need to pass the -03 flag to trigger this new ML-enabled PGO. So -03 is optimized for peak throughput. It takes a bit more time, but it gives you better peak throughput. So you can do different GCs, but in general, it is my observation that if you want to have good peak throughput in native image, you need to do G1 GC. So G1 GC will consume a bit less memory than serial GC, but in general, it will give you better peak throughput and better latency than serial GC. And then the last, and it's kind of small one, but it's still effective, is mark native. So this flag instructs native image that I want to execute the application that I am building specifically on this machine. So please optimize it for the specific hardware features of this machine, as opposed to compatibility for other types of machine within the same operating system and architecture. So this is squeeze the most out of this machine. It will not be deployed anywhere else. And this combination of flags, PGO, G1 GC, and mark native will most likely give you the best peak throughput with native image. Now let's reveal the results. And our native image run out of the box gave us 1.1K requests per second. And then native optimized gave you 1.7 requests as opposed to, 1.7K requests as opposed to 1.5 on the JVM. Now, I'm not necessarily making claims that native applications will always be faster than applications executed on the JVM. This is rather to get across the point that if you know which optimizations to apply, you can get good peak throughput with native image. And as we were running our benchmark, we were doing one more thing because I think resources usage is very important. So if we go back here, this is our project folder, and we have those nice charts produced for us by PS Record. Let me just open it side by side. So this is JIT, this is native, and this is my native optimized. So let's see what kind of conclusions we can draw here. And the way to read this is the output of PS Record, and then to read this, the horizontal blue line that is memory usage, and the vertical red lines that is CPU usage. And then the scale, the axis for CPU is on the left, and the axis for memory usage is on the right. So what we see here is a number of things. The JVM, remember we were waiting in the beginning for 10 seconds to start because it's our observation that, again, on this particular machine, it starts in about 5 seconds, and then just to be on the safe side, we gave it 5 more seconds of buffer time. And we see that indeed it seems, in terms of CPU and memory usage, it seems quite active for the first 5 seconds, and that it kind of more or less stabilized and it's waiting for the workload to come in. Now, then when we actually hit it with this high load for the warm-up run and for the benchmarking run, we see that the JVM is quite busy because it sees that more and more parts of the application become warm and need compilation to be fast. So it utilizes heavily the CPU and memory to make that application go fast. And for memory, it even goes a bit through the roof for the metrics defined in this chart. While in the native image world, it looks quite different, the whole profile of the resources consumption. So remember how I told you we are waiting for 10 seconds, but it's basically pointless. We are just waiting so we can have apples to apples comparison. But indeed, the application just started. There is a bit of CPU peak, and then it just waits for our workload to come in. In terms of memory usage, all 3 applications ran with the same memory settings, but the JVM used quite a bit more memory, while native in the out-the-box kind of configuration, it used, I would say, at peak 200 something megs. And then this last version that was also significantly faster than out of the box, it did use a bit more memory, but still less than the JVM version. And CPU also stayed quite reasonable. So this is what I said, that in general, if you're using G1 GC, you probably will have a bit more memory usage. But again, it seems fair to trade off memory for peak throughput, because obviously you cannot just get throughput out of nowhere. Usually you need to provide some kind of resources. So in our case, it is memory, but I would say this is still reasonable for having good peak throughput. So those three things, PGO, G1, and MARC native, will give you good peak throughput for native image. Let me close all of this. And to summarize this section about performance optimizations and compiler flags in native image, so there are more. We will not go through the details, but in general, if you want to experiment with native image, those are the optimizations levels that we have. So 0 until 3, those are optimizations level going from null optimizations. Typically, you will use this for debugging, where you don't want your code to be heavily manipulated, so you want it to be as close to source as possible. To 03, where this is all optimizations, give me the best peak throughput, but this will also make up for a bit longer build. So typically, we default to -02, which is reasonable performance and reasonable compilation times. Now, additional things is -OB, what we used in the beginning for having a faster build. -OS is something that you can use to optimize for size. We introduced this not so long ago. So maybe if you want to have smaller native executables, or if you want to have smaller container images, you would pass -OS. And in my measurements, especially on like Spring Framework kind of application, it gives me maybe 30% smaller images. And PGO is, again, you need to provide profiles, but if you provided profiles, you can build an optimized image, and it will also, under the hood, trigger -03, so optimize for peak throughput. But also, if you don't want to use PGO, if you don't want to do this kind of training run, you can just pass -03, and this will apply all the compile optimizations that we have, and this will also use ML PGO to try and infer the profile of your application. Now, let me see how you're doing on time. 2 minutes. Okay, let me think if I want to try to cover deployment in this section, or if we want to make a break. I don't think I can cover deployment in 2 minutes, so let's make a quick break and come back in 10 minutes. Okay for you? Yeah, see you in 10 minutes. So I used the break productively. I have compiled or built my container image that we will look at. And you can tell that it's a live one because I even broke it, because I started typing an annotation and I never finished it, so the build broke. But I fixed it, so now it's all done. We will look at the container images and deployment options in a second, but I do want to address some immediate feedback that I got during the break, which I think is very nice. So some people came to me and asked me questions and provided feedback. So I want to take a step back and address those questions that I got during the break very quickly, because I still have a lot of stuff to cover, hopefully. So the questions were two. What are the drawbacks of using native image? And I kind of thought that I covered it, but maybe I can once again repeat it and make it more explicit. So when I come to conferences, I often get this question that people think is a tricky question, like, when should I not use GraalVM? And my answer is always use GraalVM, but choose for yourself which edition works best for you. So I told you that which version rather works best for you. So I told you that GraalVM is a JDK. You can run applications on GraalVM as a JDK, or you can compile them with native image. So you do get those options. Do I want to do JIT? Do I want to do native image? It's never, all the way one or the other. And the rule of thumb will be, if I want to stay in the JVM world, if I want very easy migration, if all I want is maybe a nice latest JDK with additional performance optimizations coming from a better compiler, then JIT might be a better way to go. Now, if I want to go with native image, what I get is fast startup, low memory usage, smaller packaging, better security, smaller resources usage when it comes to CPU, memory, electricity, etc. But I was specifically asked to talk about drawbacks in native image, and the drawbacks would be, A, the build process, as you see, will be a bit longer than your normal Java packaging process. On average, for me, now I can compile almost any, I would say, Spring app that I work with in like 1 minute. At worst, it will be 2 minutes. But indeed, the build times is a bit longer than on normal Java. And then libraries. So again, as we saw in the demos and in the hints, some of the libraries would require a bit more work for you to compile to native, especially if you want to use a bit like all the libraries that haven't added support for GraalVM yet. You might run into some issues. But normally, if you start a new project and you're using the latest versions of frameworks, libraries, etc., you should never run into any of that. So libraries might be a part that you need to figure out if you have some older ones. And then for peak throughput, as we have seen, if you wanted to have peak throughput on par with the JVM, in addition to what you get already, so in addition to fast startup, lower memory usage, packaging, security, if you want to have good peak throughput, you need to apply a few more optimizations yourself. So that will give you the best peak throughput. So this was to cover kind of trade-offs. If I want a smooth, easy migration and easy performance win of around, let's say, 10-15%, I would go with GraalVM JIT, and I'm staying on the JVM world. If I want to go with native image, I need to be prepared for the maybe slightly longer build times. I might need to figure out config for all the libraries, and then to have good peak throughput, I would need to do PGO or rely on this ML-enabled PGO. This is one of the questions that I got during the break. And another question that I got was licensing and versions of GraalVM. Indeed, I maybe could have done this in the intro. So GraalVM comes in 2 editions. We have GraalVM Community Edition. It's fully open source. It's on GitHub. I believe we are one of the biggest Java open source projects out there. Like, you can correct me if I'm wrong. And then we have a version from Oracle called Oracle GraalVM. And that is something you can also use in production under that license. And I'm not supposed, I believe, to comment any further because I'm not a lawyer. I'm supposed to tell you, please consult your lawyer. But the TLDR is you can use it in production, including all those commercial features. But please do check out the FAQ. I hope I covered those questions that I got during the break. And now let's talk about packaging and deployment options for native image. So when it comes to deployment, probably one of the first questions you would get would be container images. So how can I deploy applications built with GraalVM and native image as a container image? And I see my local authority for container deployments, Matthias, here in the room. So I'm getting a bit anxious to talk about it, but let's see. So I told you that I used the break productively, and I have compiled my native image that I will have then running as a container image. And for that, I have many options how I can make it happen. And for that, probably I need to take a step back and talk about linking options in native image, because this will be important for our image sizes and what we can do with native image. So let's talk about linking options. All the applications that I have built so far with native image, it was this first version here, which we call fully dynamic. So this means that my application is self-contained as far as my application code goes and my JDK and dependencies code go. But I do need some libraries here provided by the underlying layer, being an operating system or my container underlying layer. So this is what we call fully dynamic, because your application is self-contained, but it does depend on some libraries being provided by your underlying layer. And this is one side of the spectrum. There is the other side of the spectrum, which is called fully static. And that is where you can fully statically link in all of those libraries and have them inside that native executable. And this is the opposite side, because here you can have a truly or almost truly self-contained application with everything that you need inside that app. And this means that your application will depend very little on the underlying layer. You can even put it in a from-scratch container, and then everything that is needed is inside that application. So when to go for which? The fully dynamic one gives you a bit more kind of freedom and flexibility and decoupling, because your application code, including the runtime components, is decoupled from those underlying dependencies. So it's a bit more loose coupling. And then if I need to deploy a new version of my application, or maybe I need to update those dependencies coming from the operating system layer, I can do this in a decoupled manner. Now, the fully static version is more self-contained, so maybe it gives you a bit more kind of confidence and compatibility and predictability across all the deployments. But this also means that it will function the same in all the different environments. But this also means that I have more work to do if I need to deploy a new version of my application or if I need to patch up any of those dependencies. So you can choose for yourself, do I want a bit more kind of loose coupling here on the left, or do I want more predictability and control here on the right? But then this one you can put in a very small, minimal container. So as I was talking during the break, I have built a new version of my application. And in general, we can look at the containerization options that we have for this application. I have a bunch of files here that we can explore. So we have a few for JDK and JLink, but that's less interesting. Switching to the native image world, what we have here is we are pulling the latest GraalVM for JDK 24 native image from our repository. And then we are building our plain native image application like the one we have built here locally on my machine. And then for the deployment, we are choosing a slimmer image. And in the end, we just copy and run that one application to that final image. And this is what we did during the break. So we see our normal image output. So this is native image, but building inside the Docker container. And then we can hopefully get this and run it. So let's try this. Docker run p. And this is our new image. And again, we see this familiar native image output, and it starts in 63 milliseconds. And then if we go here, only it's hello, I think. We see our familiar native image output. This is slightly mind-bending for me, at least, because this is my local machine running VS Code connecting to a remote instance, which has Docker running with this Spring Boot application running inside the Docker. So this is like layers and layers of abstraction, but it does all work. So this was just one way of building native image, but I have a couple more, and I have them pre-compiled for the sake of saving time. So let's explore them. And let's do this. So here we see the same native image application, the same Spring Boot application compiled to a container image in all the different formats. And now we will compare the sizes. So what I see here is I have first created a plain kind of JDK deployment where I have my Java base and I have my Spring Boot application, and the size of that was around 480 megabytes. Now I try to turn it down and strip away all the things that I don't need to see if I can get a smaller image. So as a next step, I built a distroless image, and this was quite okay, I would say. We reduced the image twice. But then again, by using JLink, we got even a smaller image. And those three, this is still staying in the JVM world, where we are running application dynamically on the JVM. Now, with native image, funny enough, the first image that we got out of it is around the same size as JLink, which was a bit, counterintuitive, but also it will still have those benefits of native image, namely fast startup, low memory usage, etc., security. But this is not the most optimal version of native image. We can then move it even to a smaller image by, first of all, statically linking the application. So the same Spring Boot application statically linked with everything that it needs will be 95 megabytes. And then we can take it even further. Remember, there was this -03 flag that optimizes the image for size. So not necessarily for peak throughput, but it gives me the smallest possible image sizes. And then with that optimization in place, we got the image down to just 59 megabytes. So this is quite good. In case you are a more visual person, I have a similar in a format of a chart. Where is it? GraalVM deep dive. Here. Container image sizes. So this is a simpler application. This is a JDK web server put in a similar scenario where we take the image size from JIT to the smallest we can get with native image. And you can see how going with native image progressively reduces the image size just down to 18 megabytes. So this is what you would do if you want to do container deployments with GraalVM. And here, another common question that I get, what about cross-platform compilation? So can I compile, let's say, on my MacBook from my Linux remote instance? And the answer is no, because we need some JDK classes that are specific to each platform. So out of the box, unfortunately, you cannot do something like native image, target platform is Linux, and compile it on macOS. The answer to that will be to use CI/CD systems, or then to use things like, let's say, GitHub Action. So this same repo I have set up with GitHub Actions, native Spring Boot. And here what you can do, you can use our GitHub Action, and that will produce for you native image builds. So for example, here on the latest push that I have done to the repo, I have my native image build report. And as the output, I can specify for which platforms I want to build. And this gives me my native executable compiled for all the platforms that I have chosen. So here I'm testing for and building for macOS and Ubuntu. So when it comes to cross-platform builds, I would suggest that you use CI/CD systems. And in general, it's our recommendation for working with native image and a good developer practice. And this also answers questions about developing and building and testing applications with native image, and how often should you compile to native image. This is also a question that I quite often get. And the answer is we see native image as a deployment step in your development process. So we recommend that you develop your application on the JVM, you get use of all the best tooling, etc. And then you compile to native image maybe in your CI/CD, let's say once a day. Or maybe you want to compile when you're introducing a new dependency and you want to make sure that that dependency still works with native image. So then it will be a good idea to compile and see that things still work. Or if you are touching things that are sensitive to native image, so if you explicitly touch reflection, serialization, etc., then you want to again recompile and see that things still work. Other than that, especially if you're introducing changes around your business logic, it's not necessary to recompile all the time. If you are staying in that world of supported frameworks and libraries, you will be just good. And I suggest that you compile to native in those cases where you make critical changes, or in your CI/CD, let's say, once a day or whatever is your policy. So here we talked about deployment options, and now let's talk about security. So this is a very fun topic. I like it a lot, and the reason I like talking about this is because native image has something which I call security by design, and I think this is a very unobvious benefit of native image. So native image, as we said, compiles the application ahead of time under a closed world assumption. This means that it adds, in a way, an additional security level on top of your normal Java applications, because then a number of things are not possible to attack when your application actually runs. So, for example, no class loading is allowed at runtime in native image. Everything needs to be known at build time. So this means that your application cannot just load new random classes when it actually runs. And there is way more predictability and stability in what your application does and how it runs at runtime. Then, as we said, things like reflection and serialization are possible in native image, but they require a specific allow list. So in a way, you have more awareness and more control over your application, because those things only happen if you allow them to happen, or if your framework and library configures them to happen, but they will not happen without clearance from your side. And then there are some attack vectors, maybe less popular, but they still exist, that target the JIT compiler specifically. This just isn't possible in native image because there is no JIT compiler. It's all AT compiled. It's all machine code at runtime. But we also want to make sure that you have good industry-grade vulnerability scanning and security tooling in native image. And for that, a while ago, we have introduced SBOM support in native image, so software bill of material, where you can build an application and also have for it available SBOM, which tells you what's inside that application, and you can use to analyze your app and see what is inside and if it's vulnerable or not, and which dependencies are in the application. So let's take it for a ride. And this will be the latest and greatest. What I will show here today was just introduced to this kind of extended support in the latest version of GraalVM. So let's just clear this, and let's build actually a new version of this app. Maven P native, SBOM native compile. So this will pick up my normal native profile because I want my application still to be processed correctly by Spring IoT, but also it additionally picks up some of the properties from the SBOM profile. So let's see what's in there. So this is my SBOM profile, and this is what I'm doing in addition to just normal native compilation. So as we said in the first part, this build args is the part where I can pass all the different arguments to my native image build, whatever I want to configure, such as image name or pass additional arguments to the build, is something that I configure here in the configuration section of the native Maven plugin. And here I'm doing a number of things. So I'm saying enable SBOM equals class pass and embed. This means I want my SBOM embedded in the native executable, but also for the sake of demo, I want it at the same time available as a class pass resource in the native executable. And I'm also using this application to demo additional tooling that we have in native image, and namely build reports. So for that, I'm passing two additional flags, which are PGO, so we can pick up the profiles that I have collected from my app. And also we are doing build reports, which will produce an HTML report of my application. So let's see how this is going. Okay, amazing. As I was talking, it actually even compiled now. And this is again to address the build times. I think 58 seconds for a fully blown Sprint application. It's a fairly decent result. So as the output, we got this demo SBOM application. Then we can now scan with our vulnerability scanner. Let me just clear this and move this high up. So native image gives you a lot of tooling for working with SBOM. What I will do here, I will do this, native image inspect, and I specifically want to extract the SBOM. And the application that we have compiled is the one called demo SBOM. And then maybe I want to feed it into, let's say, GraalVM. So it looked at my application. It correctly detected that there are 47 packages in that app, which I would say it's quite a bit, but that's what my application is like. And it says, OK, I have discovered all of this, 47 packages, no vulnerabilities in that app. But maybe I want to explore this SBOM further. So for that, what I can do, I can still extract it, only maybe now I want to put it in a JSON file. So let's say we call it output, I don't know, Amsterdam JSON. And also this can be accomplished with a flag. So instead of class pass or SBOM, you can build with an export flag and it will produce an JSON file with the SBOM next to your build. So this is somewhere here is our output. And let's see what's inside. So this is my SBOM. It is quite long, don't get scared. But if I can get my mouse, I can make it prettier. Yes, this is the one. So this is the place where I can see all the different dependencies and versions and what is used in my application, and then use it for scanning or use it to analyze what's inside my app. Now, what I really like and what we added in the new version of GraalVM is this dependency information. So I can see what depends on what. So somewhere here I have, for example, SVM, which is our native image runtime. And I can explore other things that are in my application, and specifically for what depends on what. I can, for example, say that I'm pulling in GraalVM for JDK, and then it doesn't pull in anything in return. And then if I keep scrolling, I can see maybe my Spring Web MVC, and I can see that it in turn pulls in some of the core Spring libraries, such as Spring Core, Spring Beans, Spring Web, etc. So I can have a better understanding of what is in my application and why is it inside that application. Now, one more thing that we have added in the last release is also what we call a class level SBOM. So this is a detailed information, but also we can do more detailed than this. So we can output for you even information specifically for each class, field, method, etc., what actually is inside your native application based on that analysis that native image runs. So we look at your whole project, and then we see what is actually reachable, so what is actually needed for your application. And we can also output for you SBOM that is that fine grade for each particular field, method, etc. used in your application. So if you're curious about a specific part of the dependency used in your app, why it's in your application, you can see it in SBOM. And also, if the security tooling picks up this level of granularity, where it will be able to tell us that, hey, this dependency is vulnerable, but only that and that part of the dependency, we can reduce the number of false positive because we will be able to tell you, yes, you are using a dependency that is in general vulnerable, but you are safe because you are not using the actually vulnerable parts of it. So you can have more fine-grained information about this, and then if the security tooling picks up, we can even have a more fine-grained information about your vulnerabilities and reduce the number of false ones. Okay, so this is how I can scan my application. Now, one more thing that I can do with the same application is I can run it, target demo SBOM. And then when it runs, it was also built with Spring Actuator. So what I can do, I can go to the Spring Actuator, and it has a very nice integration with native image, and it knows that on this endpoint, it can pick up and expose my SBOM. So maybe this is not something that I want to expose to the outside world, but maybe if I have some applications running at my company, and then, I don't know, my security team comes to me and wants to scan what we are running, see if we are vulnerable, if we need to upgrade something, I can point them to that URL, and they can just have that information available to them. So I think this looks all nice and good, and it makes maybe for a nice deployment if I'm a developer working on this app, but this makes, I would say, for a slightly less exciting demo, it will be nice if we actually found something vulnerable, right? So let's see if we can do this. For that, you will go to a different folder, native Spring Boot, that has a promising name, vulnerable. And that is a very similar version of this application. Let's super quickly take a look. That's the one. It's all very similar. I have added just one small change here. So we are pulling in the JSON dependency, and I also made sure to specifically use it actively in the app so that native image will not strip it away. So we have now this version of the application, and let's scan this one. Let's do this one, and in this folder, we have a version of this application compiled also with a similar name. So now if we scan this one and we put it into GraalVM, we see that actually it did find those vulnerabilities. So it does complain that there are two, and they are even two pretty bad ones. So this was to cover the security tooling in native image. One last point here, I mentioned a couple of times that we have GitHub Action for GraalVM, and that GitHub Action is also integrated with our SBOM functionality. So in our GitHub Action, you can enable SBOM support, and then we will use the GitHub's API and access to them, and namely the dependency and vulnerability scanning, and you will be able for your GitHub projects scan and have SBOM available to see which dependencies are in your project and which vulnerabilities are also in your project. Now, let's talk about monitoring. So this is also a question that we get a lot, that there is tooling, obviously great tooling in the Java ecosystem to have monitoring and observability for our applications. But what about native image? So what of that tooling works with native image, and what is the recommended tooling to work with native image if you want to have a better understanding of our systems, how many resources they consume, how they perform in terms of health, etc. So there are a number of things where we can talk about here. The first thing I want to bring up is the micrometer framework. Anyone in the room knows it? Micrometer? Okay, quite a few actually using it in production. Almost the same people. Amazing. Okay, then I don't need to do a lot of introductions. It's a very nice framework for kind of monitoring and observability of your application. In my head, it's very connected to the Spring ecosystem, but in reality, it's framework agnostic. It works with many other frameworks out there in the ecosystem. In particular, I want to give a shout out to the Micronaut team. I believe they have a very nice integration with the Micrometer too. So there are many frameworks from which you can use Micrometer. And I want to see it in action with native image and see if we can get a better understanding of our system of two applications running and interacting with each other. So let me see if we can run this as a demo. And for that, let's go here, observability, and this one. And again, let's clear this. Okay, so this one will be a tricky one because it's somebody else's demo that I adopted from the nice Micrometer folks. it never failed me, but it still gives me a lot of anxiety every time I need to run it. So let's see if we can run it. And this setup will start our kind of observability backend. And now we need to get our actual applications that we want to observe. So for that, I have my server application already compiled. So this green one here is my native executable. I can start this one. And we need to get one more application that will talk to it. So for that, we will start our client application. Okay, so those two are two Spring applications talking to each other. You can see how they're interacting. The client one goes to the server one to get a response. The response gets back, so they are interacting. And also we have our backend running to see if we can get some insights into our system. And both applications are Spring apps using micrometer, compiled to native image and interacting. So for that, let's go to our dashboard and let's see if we can actually explore our applications. Okay, those are our dashboards. Let me just close other things. Okay, and then it takes maybe a minute, maybe a couple of minutes to propagate. Let's give it a couple more seconds, and hopefully we will be able to see data from our app. Okay, so this says I got a request. Let's maybe explore this one, and then we can drill down into this one. So indeed, we can see our client sending a request to our server application. We can see the duration for each of those operations. And here we can also drill down and see logs for this particular span as well. So we can have more information here. So this is one way to do it. And also maybe we can close this one and see if we have our service graph available. Let me see. Maybe we want to do the gray layout. And here maybe we want to look at the request rate. So here it just started, but over the time you would see those request times coming in, and we will have nice charts and understanding of how our applications interact. So this is one way to have more observability into our system, and I quite like it. I think it's a very nice visual way, and it also gives us a lot of information. And the way this came to be, I just compiled those applications to native image, and it just worked. So again, kudos to the awesome Micrometer team. So this is one way of running such applications. I also want to show you a bit more maybe like local way of running and seeing what our applications are doing and how they are performing. Anyone here using GraalVM? Okay, some people, but fewer hands. Just for the sake of completeness, let me see if we can do something fun with GraalVM. And also, by the way, did you know that you can do this with GraalVM? So you can also install GraalVM with SDK man. I'll be honest with you, I didn't know this until like maybe a couple months ago. So I think this is pretty cool. So let me launch GraalVM, but here on my machine, I already moved to the future, to GraalVM for JDK 24, and GraalVM is still pending release for GraalVM JDK 24. So here I need to do some magic incantations. Let's see, JDK home, and then I need to manually pass my GraalVM 23 installation SDK man, no, with a dot. SDK, if I could type, SDK man candidates Java 23 Graal. And it will be nice to switch this with SDK man, but somehow GraalVM doesn't like it. It needs to be done this magical way. Okay. Yes, we are on. So this now runs, and now we need something to observe. So for that, let's get ourselves another tab, and let's run some application that we can monitor. In our case, it will be, again, a Spring app. And here I have a bunch of versions of this application compiled with different options, and I want the monitored one. So that one is compiled with flags for monitoring, namely with JVM stat for GraalVM, and also JFR and heap dump. So most of the native images capabilities, the ones remaining are JMX and JCMD. So let's run this application. This will be target demo monitored, and it's on. And when we go back to our GraalVM, we can already see a view for our application. So GraalVM can actually see it and correctly show it. But it will be more fun if we actually hit it with some load. So for that, let's get ourselves an endpoint. And that one we can hit with load. Let's say we want to send and equals, let's say, this amount to the endpoint. And this was super quick, kind of load testing, just to see that it's in action. And indeed, we can see some work happening here. So we can see that our heap usage is changing. We can see that we got more threads. So indeed, this reflects our application under some kind of load. So I think this is also a fairly nice way of monitoring native image applications. Moreover, there are more things you can do here. You can get an overview of a system, such as where this application has been built on my GraalVM for JDK 24. Or another thing that I can do here, from here, I can take a heap dump of my application, and I can go and explore what is inside my heap. So this application is fairly simple, but you get the point that this is one more way of exploring what's inside my application. OK, so let me just kill this, because I know that I will run into running the same on the same port something else. Let's go back to our overview. So here we have covered monitoring, and we are doing quite OK on time. So let's talk about additional tooling that we have in native image. So additional tooling I want to bring up, which I think is very nice, and it's not always that people talk about it, is we have build reports in native image. Where is it? Here. So if you want to maybe see what's inside your application, why wouldn't this open? Yeah. So you can build your application with a flag that is emit build report, and this will produce for you this report that gives you a bit more visibility into your build. And especially, I think this can be useful as a part of your CI/CD. So maybe you want to compare over time, let's say, with each new commit or deployment of my application, how it changes the analysis, the duration of my build, the resources consumed for my build. So I can see that if I added a new feature or new dependency and suddenly my build blew up, I can better track when it happened and why. So this first overview summary tab gives us an overview of that, and there we can also drill down into specifically code area and that image heap area of my application. So in the code area, maybe I want to specifically filter by methods that are ahead of time compiled, and this is by packages, but here I can also drill down to explore which packages and parts of them contribute to my application and its specifically size when it comes to the code size. So if I drill down into Spring Framework, and here maybe I want to do actuate and keep going down, and it shows me data for the machine code size for each of those parts of my application. So if I want to see what contributes to my application size, or maybe what are the areas where I can reduce that image size, this will be tooling for that. But this is only for code. If I want to explore my image heap, I can go here. And this will give me my application's information of what is inside the heap and what makes it up, so I won't reduce it. If I want to reduce it, this is a place where I can do it. It also gives you resources overview, and it even shows you things that we think should have been in the application, but somehow were missing, so did not end up in the executable. And then things that are injected, such as injected by your framework. And that is also yet another way to look at SBOM. So I think I like more working with SBOM directly. But if you are doing build reports anyway, they will also give you a SBOM overview in your build report. And lastly, this application has been compiled with PGO, so with the profiles flags. And this also gives me a nice drill down into my application's profile from that instrumented run. So the way to read this, the TLDR, is that the width of the each bars is how much time is spent into each particular method. And then those kind of children methods on top contribute to the ones on the bottom. So here I can see where my application spends most of the time. This one looks maybe a bit not standard, because this was my Spring Boot application running under a very high load, because I wanted to make sure that it is properly warmed up. So here it's quite busy, but honestly it spent most of the time processing and filtering my requests. And this is also interactive. So if I think I have some specific method to blame, or maybe I want to see a better understanding, have a better understanding of what's inside here, I can search for specific things. And then here I can filter by web and see all the different methods that are part of the web module and how they contribute to my application. OK, so those are build reports. And hopefully this gives you enough tooling to be working with native image. Now, I'm thinking if I want to show you scary Linux tooling or if I want to move to the latest updates in native image. Do we want to see scary Linux tooling or not? Of course, okay, I almost added one. Oh my God. Okay, just to manage expectations, it will not be super scary, but this will not be your normal Java tooling. Let's take a look then. Wow, there was really no disagreement on scary Linux tooling. Wow. Okay, so the reason I want to bring this up is because what native image does for you is it gives you a way to program your application in Java, so with all the tools and developer experience that we like, but at runtime we get a behavior of a native program. And this also means that you also get the tooling that you have for native programs available to you with a very good, like fine granularity and very good detailed information. And this means, for example, that you can use all the tooling, let's say, available in Linux to monitor and profile the applications and get a better understanding of how they behave at runtime. So it's not that you have to use scary Linux tooling, it's that you get to use scary Linux tooling if you want to, because at runtime it's a native program and you can get a way better understanding of what the application does under the hood. By scary Linux tooling, in this case, I mean just perf, which is not even that scary, but it does look slightly, I would say, more scary than Micrometer and GraalVM and all of that. But to put that into action, let's take a look at yet another app. So we have here a little event application that in the past we have built with my colleagues from the Java team, where we wanted to showcase the latest Java features and also compile it to native image and showcase how native image makes the Java application even more awesome. And in the essence, this application kind of emulates a conference app, something that we also have here. And the main part of it is that it has this event schedule where it looks at our session information, so the one stored here, and it tries to output conference schedule in a way to give you time and whether or not you need to go to that session, what happens here next. So the TLDR here is that that application runs something like this. Let's run the native app version of this app, and then the JVM is the same. So this goes through my sessions file, and it outputs this information about the sessions available at this conference and the times of which. And the point where I want to show specifically this application and not use our previous ones is because it's a batch job, so it's very timed. It just gets something done and it shuts down, and it's very convenient to measure this one. So we have a native version of this app, and obviously we also have a Java version of this app. And I want to very quickly run it with perf. We can do more things. We can do time. We can do PS record during the break. But I want to super quickly run it with perf and see if we can get some better insights about this application. So the first thing that we can do, we will run this with perf. I think we should just do this perf start JVM. So this no-brainer will run my application on the JVM with perf attached to it and will output information about how many resources it consumed. And then we will do the same, only we will do a native version of this application. So that will be perf start native. And this will run also with perf, but a native version of our app. So let's run it on the JVM, perf start JVM. And it's timed, so it's like get my task done, process the file, and get back to me ASAP, kind of like the 1BRC, but in a much more kind of simplified version, let's say. So here we see a number of things. You can clearly deduct more kind of insights from it. One thing that I like looking at is CPU usage and also how my instructions were executed to get this job done. So the CPU usage for this job, which was executing the application on the JVM, was at 48.5 CPU. In fact, it used to be around, so this is what, like roughly 48.5% CPU. In the past, this used to be around 100% CPU. I guess I upgraded the application for Java 24 and already made it faster and better in the JVM, but still quite a bit of CPU, I would say. And then the instructions count for this version of the application is 1.1 something billion of instructions to process this file and give us the output. Now, if we take for a spin of a native image application, and that does the same thing, only it processes the file and outputs out the output as a native version application. So previously we had 48.5% CPU used. Now it went down, I would say, order of magnitude even a bit more to just 3% of CPU. And then for the instructions count, it was 1.5 billions before. And I know those numbers are kind of hard to grasp, but this is around 13 million instructions. The TLDR here is, or rather like two TLDRs, is native image uses less resources at runtime because it doesn't need to do all that expensive class loading, profiling, compiling. And also you get to use fun tooling like this to drill down even further into your native image and get even more insights into what is possible with your native image and where you can optimize it even further. So this finally concludes our monitoring part of talking about native image and what you can do. And here I want to switch to a section that I think is very fun and that I called for this talk in the lab. So those are the things that we are working on, but they're not maybe fully done yet. But I want to already tell you what are the next big things planned for GraalVM. This here is unofficial, but I do feel like our team has those kind of unofficial slogans. So if you talk, like we are a serious team, we work on a very serious project, but we are still Oracle Labs. We do a lot of R&D, and we do a lot of brand new projects. And sometimes when we do something a bit more like groundbreaking and exploratory, the question is, why do it? And the answer is quite often because we can. So we do both serious things, but also some things that in our project we do just because we can. And also we literally have several people in the office with like coffee mugs and everything saying we did those things not because they are easy, but because we thought they would be easy. So this is the slogan for all some of those kind of more groundbreaking things that we will be working on. And I want to start this with this very cool project from my colleague Alfonso Patterson called llama3.java. So Alfonso is a colleague of mine working on Espresso or this Java on Java implementation. But in his free time, he does a lot of cool things. And one of the cool things that he did was he implemented an entire LLM inference engine in Java. And it's a single file Java project where your entire inference logic, and inference is this kind of predictability capability of LLMs. So your entire logic is implemented in Java. And then that one Java file, along with a model file, gives you a fully implemented locally Java LLM engine running fully locally with no access to internet, no access to anything like OpenAI, and even no need for GPU, just on CPUs. For that, I would need to switch to a different machine where I have my all LLM-related things stored. And let me see if I can get this one up. OK, looks good. So my entire project is literally this llama3.java single file project. And it's not even that big. It's maybe like 2.5K lines of code. And this is my entire logic that defines how my model reads my input, interacts with me, provides an answer to me, how it chooses the next token, etc. And this one Java file, along with a model file that you can get from places like Hugging Face, etc., gives you a complete local LLM inference engine. Now, I do not say that this is necessarily a replacement for something like OpenAI or Claude or Gemini or something, but this is a very fun way to see where modern Java can take you, because this uses under the hood the FFM API in Java and the Vector API in Java. So we need FFM to interact with this huge native file, and we need Vector API to make it fast. So this is using all the latest and greatest from Java, along with optimizations from GraalVM to make it even faster. And I have it compiled already here as a native image. So this is my Llama AOT just native image. And this is with some additional AOT optimizations that completely eliminate this startup. And let me see if I can get it to run. And if not, we will take a look at the pre-compiled version. Actually, maybe I can just pick it from the history. Let's see. OK, so you can see here that this startup was literally 0 milliseconds. And then if I say hello, I don't know, I can ask, what are you? and it will tell that this is an artificial intelligence, etc. And it actually has quite good awareness of the outside world because this is Llama 3.2, so this is a very good, I would say, quite production-grade model. So I can even ask it, I don't know, what is GraalVM? And it should give me a decent enough answer. And again, this is running fully locally, compiled with native image on my machine, no access to internet, no GPUs, no anything, just a small, tiny, little native program. And it even gives you a reasonable output of what is native image and what is GraalVM. So I think this is pretty cool. And again, the goal of this project is to showcase capabilities of modern Java and where it can take you. But also, I think this is pretty cool, and there is a request in the community to release it as a library. So we are currently trying to see if we can make it happen. With that, let me go back to our previous setup, because there are more things that I want to talk with you about. So the next thing I want to talk with you about is actually a very big flagship project in the native image world, and this is our native image layers. I have time until 4 p.m., right? Because this thing gives me that I have 4 minutes left. Does anyone know? 4 p.m., right? 2 hours straight. Okay, perfect. Okay, no, it's all good. I think I can manage in time. Thank you. Okay, so what is native image layers and why is it a big deal? So remember how I told you that we are working on native image build process and innovate to make it faster? So this is one of the ways how we think we can make native image builds faster. And this is a big groundbreaking project for us, and this is why. So the way you build native image, the whole promise of it is that you build a fully self-contained, fully working on its own big native executable that includes everything that you need for a deployment so that your application can run. But we thought, what if we introduced layers? So you can think of layers as kind of like shared libraries, or better yet, as in layers in Docker deployments, where you can once say that I have my dependencies. Let's say I have a Micronode application or a Spring application, and I can once compile all those base layers, kind of like you have layers in Docker that build upon one upon another. And then when I need to recompile my application code, I only recompile the application code, and the rest stays provided to me in this base layer. So now every time I need to introduce a change to my app, I only recompile the code that I wrote, and usually it's a very thin layer on top of layers and layers of dependencies. And this way we believe that we can take compilation times down to probably matters of seconds as opposed to, let's say, 1 minute. Because my base layers will be just available to me as this base layer that is always compiled and available. So this will give us better build times, but also we believe this can be interesting as a deployment technique, because let's say I want to deploy, I don't know, 5 versions of my Micronode application, 5 instances, or maybe even 5 different Micronode services that have the same dependencies underneath. And what I can do in that case, I can deploy my base images, maybe that is my JDK base, my Micronode base, etc. And then those 4 or 5 instances can reuse those base layers, and I can have this resources sharing in the cloud where those instance layers can benefit from accessing the same base layers, and I don't need to recompile and redeploy those base layers all the time. So this will be a very big project because this is changing quite a few things for us. But I do think that maybe with the next release in autumn, GraalVM for JDK 25, we will give you a first kind of version to give it a try and see it for yourself. But we do think this will take our deployment and build times much further down. Building upon layers, we have this another fun project called Project Crema, and we haven't talked about it publicly yet, but I think we should. So this is also a very big project, and it builds upon layers. And in that case, what we are thinking is, what if you do have your layers, only then your top layer is not necessarily compiled, but what if your top layer is a JVM bytecode interpreter? So suddenly you can load classes dynamically because now you have open world. So if this layer is interpreted, you can load whatever you want from the outside world. And let's say you want to have application where something unknown can happen at runtime, suddenly you can have your base compiled, but that top layer will provide you this open world and the ability to dynamically load new classes at runtime. I think this will be very exciting and it will open many new possibilities for native image. So I'm really looking forward to Project Crema. Stay tuned. I think we should publish more information about this very soon. Now, again, talking about groundbreaking things for native image, there is this new very cool flag that we are introducing into native image. So you can see that this is already merged, but this is not something that was available in the previous release. Probably it will be something that you can try in our next release in autumn. So this flag has options. It is age preserved, but then you can do either all or with some level of granularity. And what this does, in case of preserve all, it will include everything from your project into that native executable. So maybe you just want to compile your project and just literally put in it everything that is there. You don't want to strip away any of the packages, any of the dependencies. Maybe you want to have just one big native image with everything in it, but then you will have way fewer issues with libraries, something reflectively accessed in one of your dependencies, etc., because it will all be compiled in this native executable. And this will have some toll on the build time and the size of the image, obviously, but also we see that it can be more fine granular. So for example, you will be able to only include a particular module or package because you think that that one might be problematic or that one is critical for your application and you want to have it completely available in the native app. So we want to give you, but also the framework authors, a way to include more in the native executable, either your entire project or per package or module, what you want to see in that native executable, up until you can include everything at all and not just strip away anything. So I think this will be also quite groundbreaking for native image, but also very interesting. And if you have any feedback on this, I will be open to hearing it during the break. Now let's see what else. Yes. Embedding Python. So previously here at this conference, there was a very nice talk from the Picnic guys, from Rick and Enric, I believe, talking about how they are embedding Python and GraalJS and JavaScript in a Java application so they can give their business analysts a way to write business logic rules for their Java application using JavaScript or Python. And this is not like native image per se, but this is another big part of the GraalVM project where you can run all those other languages on GraalVM and also namely embed them into Java applications. But also something that you maybe know or don't know, you can still take that Java application compiled with that, included with that Python or JavaScript or something else and compile it to native image. And in that case, we will include a runtime for Python or JavaScript in the native image, and you can have a native app that will still dynamically execute that JavaScript or Python. And this is getting a bit into like more tricky, scary area, but I still want to show it to you. Let's see. So here we have our Graal languages demos. I want to quickly see if I can show this in action. GraalPy, I think it's Spring Boot. Spring Boot, PyGal charts, this one. So what I have here, I have it compiled, and this is maybe slightly, target. So I have maybe a slightly larger application, but this includes my entire Python runtime and everything that I need from Python for that application. So let's quickly take a look at it. So this is my Spring Boot PyGal application, and PyGal is a very cool package in the Python ecosystem where I can create charts and plots using that package. And what happens here, I can have different endpoints for my app. So this is a Spring app making use of that library to produce those charts. And here, for example, I have a version of this application that uses a library where most of my logic here to build that chart is written in Python. And this is something you can do with GraalVM, where all of the supported languages can be embedded into Java using this syntax. And this is a version of the app where most of my logic is done in Python, but similarly, I can do most of that logic done in Java, still using that library, but using mostly Java to execute my logic. And what I like about this project is that in case you ever did any kind of polyglot programming, you know that one of the biggest issues is managing that whole polyglot kind of ecosystem coming together because I have my Java dependencies, I have my Python, and how do I marry my Java dependencies and my Python and my build tools. And what I really like and what our team did that I think is really great is we have this GraalVM Maven plugin, and it helps you configure GraalVM for your Java projects. But among other things, I like that it lets you define your Python packages from POM.xml, which I think is very convenient because as a Java developer, I would much rather work with my POM.xml than try to figure out all of this for all the different guest languages. So here I'm saying that I want to use PyGal, and namely, I want to use that particular version of PyGal. And we see that we have it compiled already as a demo. So if we run it as a demo, it starts even quite fast for that application, I would say. And the endpoint is Python. So if we go here and just zoom out, we see that cool chart coming from PyGal, and it's even interactive, so you can click on all the different places and see how that behaves. And Python is clearly very well known for all those data science and machine learning packages, and quite a few of them are working and are available to you from Java programs from GraalVM. So this is one more of those forward-looking projects of ours. And the last thing that I want to share here from those Java groundbreaking projects is, where is it? Yeah, this one. So what we talked about so far in this session is that native image can take your application and compile it from Java to a native image, which is a native executable, which is a native program running on your machine. But, technically there is no limit to what native image can do, so what it can take and compile it to whatever output. And one of the interesting possibilities that we recently presented at a conference at WASM.io was that we can take JVM bytecode and then compile it to a WASM module, and then that WASM module you can execute in many different environments, such as, for example, in a browser. So what we are looking at here looks like as a simple HTML page. Maybe this is some kind of Java, educational environment where you can play with Java. But what this is deployed here on our website, what this is under the hood is the Java-C compiler. So the compiler that we use to compile our source to our bytecode, compiled to WebAssembly and then deployed on our website on this endpoint. And this is all very live. We can compile it as is, or we can introduce some changes to it. So maybe I want to add more input here. Maybe I want to say something, hello from Amsterdam, and even add, an emoji. So we can compile this to bytecode, and we can see that it's a very real thing, because then we can go back and disassemble it and see what is inside it. So this is yet another thing that we can do for you with native image. This is our experimental WebAssembly backend for native image. Now, before you go and jump in and try to compile your massive enterprise Spring application to a WebAssembly and try to run it in a browser, I need to tell you that this is experimental work. There are still things for us to do, but I think this is a very exciting and very promising one more direction where we can take native image. So as you can tell, we have a lot of cool projects that we are working on. I do hope that I have convinced you to try at least some of them. With that, let me wrap up and show some final things. So if you want to get started with GraalVM, this is one place where you can start with it. You can go to our website, you can pull container images, or I'm always advertising SDKman. I love SDKman. I always use it, and I recommend that you use it. So you can just pull the latest GraalVM installation from SDKman, and we always release on the same day when new Java releases. So on the Java release dates, you also get a new GraalVM release on the same date. If you have any questions, I will be available here, but you can also just catch me on social. I guess I should update this one to now be Blue Sky or something and not Twitter anymore. And most of the repos that I have showed, most of the demos that I have showed to you here today are available on my GitHub as demos, but also I'll be here the rest of the day if you want to ask any kinds of questions. With that, thank you so much for coming. I do appreciate you coming here. This was my first solo deep dive. I was freaking out about it for like 2 weeks, but I think it went well. Thank you so much for being here and choosing to spend those 2 hours with me. With that, please rate the session. And if you have any feedback or questions or anything to say about GraalVM, I will be here and I will be there in the hallway during the breaks. Thank you so much.